All right, so I'm just going to run through the complex roots of unity, which have a couple of special properties. All right, so let's say I'm asked to solve this. Z cubed is equal to 1, and I'm asked to find all solutions for Z. All right, so to do this, I need to write 1 in polar form. All right, so I'll do that in the calculator. 1 x, y, 0, second function 8. So modulus is 1 and the argument or the angle is 0. So I'm being asked to solve z cubed is equal to 1 times the cis of 0. Don't forget to solve these ones. You need to write this in general polar form. So this will be 0 plus n times 360. All right. So I'm going to get the cube root of both sides. All right. To solve this, I'm solving for z. So cube root of this side, which is the same thing as power of a third. Should probably have a back around that. So that's just going to be z is equal to, using De Moivre's theorem then, so it will be 1 to the power of a third, which is just 1, times the cis of multiply these by a third then. So 1/3 multiplied by 0 is just 0. 360 multiplied by a third is 120. So this just ends up being the cis of n times 120. All right. So to get your solutions, to generate your solutions, you're going to sub in 0, 1, and 2 for n. Okay, so z to the power of 3, there's going to be 3 solutions. It's 0, 1, and 2 you sub in. Don't forget, you start with 0 and you're going to stop 1 short of whatever that number is. If it was z5 I was solving, I'd be subbing in 0, 1, 2, 3, and 4, for example. All right, so let's sub 0 in. So n is equal to 0. I'm going to get z is equal to, you're multiplying by 1, so you can stop writing that if you want. So it's just going to be the cis of 0 times 120. Which is just the cis of 0. If you sub 1 in then, you're going to get z is equal to the cis of 1 times 120, which is just the cis of 120. And if you sub 2 in, you're going to get z is equal to the cis 2 times 120, which is the cis of 240. All right, so there's your 3 solutions. We generally want them back into rectangular form. So the cis of 90 is cos 90 plus I sine 90. Sorry, it's cos of 0 plus I sine 0. So cos of 0 is 1, sine of 0 is 0. So this is just going to be equal to 1, okay? And whenever you're getting the roots of unity, the first solution is always just going to be 1, and then it's the rest of them will be your complex roots. The next one then, so cis of 120 is the cos of 120 plus I sine 120. So cos of 120 is minus a half. And then the sine of 120 is root 3 over 2. So plus root 3 over 2 I. The cis of 240 then is the cos of 240, which is again minus a half. And then the sine of 240 is minus root 3 over 2. So minus root 3 over 2i. And there's my 3 solutions. All right, so just a couple of things to cover on this first. If I was to plot those on an Argand diagram, my first solution is the cis of 0, which is just 1. Okay, so that would be, say, out here. All right, my next one is the cis of 120. So I go 120 degrees around. It's 1 times the cis of 120, so the modulus is the same. So it'll be the same kind of distance out. It'll just be 120 degrees. So let's say it will be there. And then the next one is 1 times the cis of 240. So around to 240. So that's 270, so 240 would be out here. And it's 1 away. Okay, so if you drew a circle, like I've done here, you'll find they're all on a circle with radius of 1, with the modulus. Okay, and they are 120 degrees away. Okay, and that 120 degrees is 360 divided by 3. Okay, now that's not a unique property of unity, okay, and the roots of unity. So if you look at one I did previously, where I was looking for the cube roots of 8, I found my answers were cis of 0, cis of 120, cis of 240. So they were 360 divided by 3. They were 120 degrees away from each other. And the modulus was the same for all of them. They were all 2 times that. All right. Just one with a complex number then as well. So I was trying to find the 4 roots of minus 2 root 3i. And I ended up with the cis of minus 30, the cis of 60, the cis of 150, and the cis of 240. 360 divided by 4 is 90. So minus 30 plus 90 is 60, plus 90 is 150, plus 90 is 240. If I did another plus 90, I'd be back round to there. Okay, so that's not a unique property of the roots of unity. It's a property of the roots of any complex number, that they will all have the same modulus. You'll see it was root 2 in this example then as well. So they're all going to be on a circle, like this kind of perfect circle here that I've drawn, and they will be evenly spaced, and that spacing will be 360 divided by what that power is. Okay. Unity in particular has a couple of kind of special properties then as well. All right. So how best to illustrate this? So the properties it has, you're not expected to learn these and know these by heart. I think if they were to come up on an exam, I think you'd be kind of talked through it, or you'd get a decent amount of prompting in the question. All right, so the properties would be, so the roots of 1, the complex roots of 1, the first one is always 1. Then you'll get some complex number. Okay, so I'm just going to call that, they often call it the lowercase omega, so kind of slightly curvy w. Okay, so the second root will be some complex number. The next one will be that complex number squared. The next one will be that complex number cubed, and so on until for the k root, it'll be that complex number to the power of k minus 1. So all that means is when I was looking for 3 roots, I would stop at that complex number squared. If I was looking for the 10 roots, I would stop at that complex number to the power of 9. Okay, so let's see, does that check out with this one that I've just done? First root I got is 1, so yep, that's fine. Let's look at these two then. So just to go back to this one here, okay, so I had cis 0 times 120. Let's nearly do demoivre in reverse, so not the typical way I would do it, okay? So the cis of 120 degrees multiplied by 0, I can move that 0 up into the power. So I would get the cis of 120 to the power of 0, okay? And then anything to the power of 0 is equal to 1. So that's just got a slightly different way, but that's why you'll always get 1 as that first real root. Let's do that with this one then. So cis of 1 times 120. Let's do demoivre in reverse. So this is the cis of 120 degrees to the power of 1. Okay, and let's call that complex number the cis of 120 r omega. And that's to the power of 1. All right. So then cis of 2 times 120, that's the cis of 120. And then instead of multiplying that angle by 2, let's bring the 2 up to the power. So again, that's just applying demoivre in reverse to the normal way we use it. So it's cis to the power of 2. So I've already said I'm calling cis of 120 omega, so this is omega to the power of 2. So there you see my roots are 1, then some complex number to the power of 1, then some complex number squared. And that's where I stop in this one. As I said, if this was z to the power of 5, I would also have omega cubed and omega to the power of 4. If it was z to the power of 12 I was solving, I'd have 1, I'd have omega to the 1, omega to the 2, omega to the 3, omega to the 4, all the way up to omega to the 11. Okay, so that's one property of unity. They will always be in that pattern. All right. The book does it in more abstractly. It solves complex number to the power of k. So you can see it done there, but this is it. This is it done just using a more specific example. All right. Other property then, which I think they could ask you. Again, you're not expected to know this. I think you'd be prompted to use it, but all the roots, all the complex roots of 1 added together, okay, so the sum of these always equal to 0. Okay, so if you're asked to get the first 3 roots, the 4 roots, the 5 roots, the 6 roots, 7 roots of 1, whatever, when you get them, if you add them together, they will sum to 0. Okay, so again, let's just check that with the example that we've done. All right, so here's my 3 roots. Let's add them together. So just add the real parts with the real parts. 1 plus a half, 1 plus minus a half plus minus a half. So that's 1 minus a half minus a half. Yep, that's 0. And then I've got plus root 3 over 2i plus minus root 3 over 2i. So that also is equal to 0. Okay, so when I added those together, I got 0. And you would find that's the case with any number of roots of 1 that you're asked to get. Okay, so as I said, you're not expected to know these by heart, these properties. I think you will be prompted to use them if they come up. The book has kind of a more abstract proof nearly of this as well, why they sum to 0, but I think it would come up with a specific number, and again I think they will prompt you to use it. So it's just so you've seen it here and you're aware of it.